Welcome to G Fun Facts Online. Imagine teaching a brilliant student to play the piano perfectly. Then you teach them guitar. But as they become a guitar virtuoso, they completely forget how to play the piano. This is the exact problem our most advanced AIs face. It's called catastrophic forgetting, and it's the single biggest barrier between the AI we have today and the truly intelligent machines of science fiction. But now, a new experiment from Google, codenamed HOPE, might finally have a solution. First identified back in the 1980s, catastrophic forgetting is the tendency for a neural network to completely erase old information when it learns something new. At their core, AIs learn by adjusting millions of connections, or weights, between artificial neurons. When you teach it a new task, it overwrites the very weights that held the knowledge of the old task. This means even our most powerful large language models are fundamentally static. They're trained in a single, massive, multi-million-dollar event, and then their knowledge is frozen in time. As AI scientist Andrej Karpathy notes, no existing system can learn continuously. You can't just tell it something new and have it remember. He believes solving this is a decadal challenge on the path to artificial general intelligence. For years, researchers have tried to slay this dragon. Their strategies fall into three main camps. First, there are regularization methods, like elastic weight consolidation. Think of it as telling the AI, whatever you do, don't mess with the brain cells that store your piano skills. It protects the important old knowledge. Second, there are architectural approaches, which build new brain sections for new tasks. It's like giving our musician a separate guitar brain that connects to their piano brain, but this can get very resource-heavy. Finally, there's the most intuitive approach, memory-based techniques. This is like having the musician practice their old piano scales while learning the guitar, rehearsing old data to keep it fresh. These methods were clever and crucial, but they were all stopgaps. The problem required a more fundamental rethink. And that rethink arrived in late 2025 at the NeurIPS conference. A paper from Google Research introduced a model called HOPE, based on a new paradigm called nested learning. The core idea is that the traditional split between an AI's structure and its learning process is an illusion. Instead, nested learning treats an AI like a series of Russian nesting dolls. Each doll is its own learning process, happening at a different speed and level, all nested inside each other and working together. This nested structure provides what the researchers call a new, previously invisible dimension for designing more capable AI, a dimension they believe is the key to finally overcoming catastrophic forgetting. So how does it do it? HOPE is what's called a self-modifying architecture. Now this doesn't mean it's rewriting its own source code like a sci-fi movie. It's more nuanced and arguably more powerful. It can adjust its own internal learning rules. For instance, at one level, the AI learns a new fact. Say, that you prefer short answers. At a higher level, it reviews that learning process. Then, at an even higher level, it can optimize its own strategy for learning user preferences, maybe making it faster or more efficient for next time. It's learning how to learn better. This is enabled by its second key innovation, the Continuum Memory System, or CMS. Instead of a simple short-term and long-term memory, CMS treats memory as a spectrum. Some parts of the memory update constantly, capturing fleeting details. Other parts update less often, consolidating important information. And the deepest layers update very rarely, holding the model's core, foundational knowledge. This mimics how different circuits in the human brain operate at different frequencies. It allows HOPE to be both highly adaptable to new information and incredibly stable in retaining old knowledge. While it's still an experiment, the initial results for HOPE are impressive. In tests, a 1.3 billion parameter version of HOPE consistently outperformed comparable advanced models in language and reasoning tasks. It was particularly good at needle-in-a-haystack tests, where it has to find one specific detail in a huge amount of text. This shows its advanced memory system is really working, allowing it to manage and recall information over long contexts far better than its predecessors. The potential here is staggering. Think of a household robot that learns your family's habits and adapts to your redecorated living room without needing a factory reset. Or an AI medical assistant that continuously learns from the latest research and your personal health data to adapt your treatment plan in real time. Imagine a self-driving car that enters a new city and learns the local driving quirks without forgetting the fundamental rules of the road. Or an AI tutor that grows with a student from kindergarten to college, constantly tailoring its approach to their evolving learning style. This is the future that continual learning unlocks. Of course, creating a truly autonomous, continually learning AI opens a Pandora's box of philosophical and ethical questions. The biggest concern is value drift. If an AI is constantly changing, how do we guarantee its core goals remain aligned with ours? A helpful AI could, through its learning, develop new goals that lead it to harmful behavior. This also makes them less predictable. How do we control a system whose behavior is constantly evolving in ways we can't fully anticipate? We're moving from designing safe systems to designing systems that remain safe as they learn and change on their own. This is a monumental challenge for AI safety research. Google's Hope AI and the nested learning paradigm aren't the final answer, but they represent a massive leap forward. It's a shift from building static statues of knowledge to cultivating dynamic, living ecosystems of learning. We're on a quest to understand intelligence itself, and perhaps to create something that mirrors our own most remarkable ability, the unending capacity to learn, to grow, and to adapt. The journey is long, but hope has given us a new and very real reason to be optimistic about where it's leading.